Hi everyone, my name is Shubhi Asthana. I am a senior research software engineer at IBM Research. Our lab is in the South San Jose in the Santa Teresa Park, surrounded with hills, and my organization works on Granite. Granite is IBM's enterprise large language models, and we have been pursuing to improve our LLM to focus on privacy and privacy engineering needs. With that, we came up with OneShield, which is our guardrails for IBM's Granite. And today I would be presenting the OneShield Privacy Guard. Essentially, I would give an overview of why privacy in LLM matters, which I don't think is really required, but still. We will give an overview of what OneShield really means, and when we deployed it, what were the key learnings and takeaways that we realized that are essentially important and needs a step forward in privacy engineering. With that, let me give you a brief overview. So, when we worked on Granite models in 2023, we realized that a large part of training data that has been crawled and put into our LLM included PII, SPII and PHI information. And of course, it was hard to detect and understand how much of the training data would be useful without this PII or SPII information. So we worked with the legal teams, privacy teams, as well as we worked with the model teams to understand how can we ensure that Granite is a safe model, that an enterprise client feels safe to use our LLM before it gives out any information in the form of prompts, or it gives out us data in the form of RAG. Since significant SPII data went into training, they got embedded into our LLM workflows, and their existing privacy techniques were causing limitations. So we came up with our own PII, which was more globally suitable for our enterprise clients. An overview of what OneShield does, it's a guardrails. Like any guardrails like NVIDIA's NeMo or Llama Guard, it's a guardrails that takes the output or the input to the LLM, searches for any data that should not be fed, and removes it out. It may block some of the data, or it may just make the prompt redundant. Some of the detectors apart from PII include self-harm detectors or adult content, inappropriate child content, etc. We have a privacy policy manager because we want to customize our guardrails that are suitable to enterprise clients. For example, for a PHI client, we want to be able to still include some amount of PHI information to pass through. However, for our financial clients, we want to ensure that all the credit card numbers, bank account numbers, and any endpoints are really tightened up to protect the user privacy. We also want to ensure that we are compliant with HIPAA, GDPR based on the jurisdiction, and the privacy policy manager ensures that it is acting as a safeguard on top of the detectors that are detecting. And then lastly, we have a regulatory policy engine, because of the ever-changing acts like the EU AI Act, we have to keep our database rules-based to ensure that we are able to process the latest AI acts that are being evolved, and based on that we monitor whether we should be blocking or restricting certain information. So this was the overall of OneShield. Then we came up with a privacy guard for this. So a privacy guard was nothing but a set of models, but each of the models was to a particular PII type. We pulled in a lot of data, say how bank account numbers look for certain countries, and provided and trained our models for just that. How do national numbers look like across different countries, and provide that information. This was not just regex based or just machine learning based, but a combination of regex and machine learning, because we realized that the contextual information of that PII detected is more important than the PII itself. Most of the PII, which are numerical based, are not giving enough learning to our models. We have to look for the contextual information around it. For example, if I say Paris Hilton lives in New York, here the entity is Paris Hilton, and a classifier may misclassify Paris as a location versus a person's name. Contextual classifiers ensure that we are looking at the context of the entity based on how the model has been tuned with hyperparameters, and provides an accuracy of which is the right PII type, or it is more closer to a certain PII type versus the other. This was very good in removing false positives when we were deciphering whether a number that we detected was a German passport number or someone's phone number in Austria or another country. When these kinds of conflicting PII informations come into structure, one must look at the context in which the PII has been detected, and also look at some of the training parameters that have been used for the model. With this, and also with the support of IBM research labs or globally, we were able to come up with models which had semantic angles added to it, that could say whether an entity, say if it is detected in Spanish, belong to which PII type, and that helped us add the multilingual support. Our models were lightweight compared to the machine learning models, which have a higher latency. We used very simple lightweight models like CNNs and naive Bayes. We ensured that our quality of PII that we trained in the model was higher, and that helped us ensure that our PII detection had a better accuracy. So with this, we were able to deploy this. Our first deployment was in a data and model factory, which is an internal IBM tool to look at how much PII data is in the particular data, as well as when a user is interacting with the LLM, how much PII or SPII is being leaked. Results was reasonably well. When this was deployed, we had a low latency, and we were able to show that we were compliant with different regulatory compliance acts. The second was an open source deployment. Now, when you have an open source deployment of a PII model, you can expect all kinds of PII information to take place. This was a setting in Instruct Lab, which is an IBM GitHub repo, where a number of developers from the development community interact with the IBM tools. A code of conduct clearly states that we do not want any PII information in PRs, yet we get a lot of PII through. We realized that not all SPII was really needed to be blocked. So we came up with what is the level of sensitivity of PII. For example, if we detect an SSN or if we detected a bank account number, irrespective of who it belonged to, we wanted to restrict it. But if it is when PII is termed, even in a GDPR Act, it clearly states it is someone's information, personal information. That means you should be able to tie in that PII to a person. So for other PII types like date of birth, location, if we are able to tie in that information entity to a person, we are able to say that, okay, this is someone's information, and now how do we rank its sensitivity. And lastly, if it's a public person's information, how much do we want to restrict that information, especially in an open source setting. Based on that, we had this deployment that was pushed. And this was in a repository where we looked at quite a few pull requests, around 1256 pull requests. We evaluated the performance for different PII types individually with Presidio, and this diagram doesn't show, but also with AWS Comprehend. And we did quite better in some of the PII types. In some of the PII types, we did marginally better or not so good. I think the reason why we are marginally better is because we have global data. So we are able to easily detect an Indian Aadhaar card number versus Presidio, which has been very well trained on US data, so it can easily detect an SSN number versus a national number from countries which have lesser data in them. So a comparative analysis we want to do, we did a deployment and we got different kinds of feedback. In an automated deployment, we did not need as much human intervention, but when we did go open source with it, we required human in the loop intervention to reduce the false positives and to understand how the contextual classifiers need to be fine-tuned better. With that, I think our lessons learned was we want to ensure multilingual support because our customers are global and the development community utilizes our tools from various countries and with various kinds of data, PII data, that we must be able to detect. We had a lot of good learning in contextual sensitivity thanks to the human in the loop feedback. And we realized where is automation required versus how much human oversight is required when we are deploying PII models in enterprise setting. With that, if one wants to use OneShield, externally this has been productized in Granite.Guardian product. We have released 2 papers around how our benchmarking was compared to the existing PII models in the market. And with that, if anyone has any questions, I'd be happy to take. Thank you.